Start by exploring what the atmosphere actually is. The atmosphere is a layer of gases that surrounds our planet, acting as a protective shield. It's made up of several different gases, with nitrogen and oxygen being the most abundant. This invisible blanket not only provides the air we breathe, but also plays a crucial role in maintaining life on Earth. Without the atmosphere, our planet would be exposed to harmful solar radiation and extreme temperature. In essence, the atmosphere is essential for life as we know it, shaping weather patterns and supporting ecosystems everywhere. Atmosphere isn't just one uniform layer. It's actually divided into several distinct layers, each with its own characteristics. Starting from the ground up, we have the troposphere, where all weather occurs. Above that is the stratosphere, home to the ozone layer. Then comes the mesosphere, thermosphere, and finally the exosphere, which gradually fades into space. Each layer plays a unique role in protecting the planet and supporting life. Understanding these layers helps us appreciate the complexity and importance of the atmosphere. Troposphere is the lowest layer of the atmosphere and the one we live in every day. It extends up to about 8 to 15 kilometers above the Earth's surface. This is where all our weather happens. Clouds form, rain falls, and winds blow. The air is densest here, making it rich in oxygen and nitrogen. The temperature drops as you go higher in the troposphere, which is why mountaintops are colder than valleys. This layer is vital for supporting life and driving the weather patterns we experience. Above the troposphere lies the stratosphere, stretching from about 15 to 50 kilometers above the ground. This layer is famous for containing the ozone layer, which absorbs and scatters the sun's harmful ultraviolet rays. Unlike the troposphere, the temperature in the stratosphere actually increases with altitude, thanks to the ozone absorbing energy. This layer is also where commercial airplanes often fly, taking advantage of its stable condition. The stratosphere plays a key role in protecting life on Earth from dangerous solar radiation. Next up is the mesosphere, which sits above the stratosphere and extends from about 50 to 85 kilometers high. This is the coldest layer of the atmosphere, with temperatures dropping as low as -90 degrees Celsius. It's also where most meteors burn up upon entering Earth's atmosphere, creating those beautiful shooting stars we sometimes see at night. The mesosphere is less understood than other layers, but it's crucial for protecting us from space debris and maintaining atmospheric balance. Above the mesosphere is the thermosphere, stretching from about 85 to 600 kilometers above the Earth. This layer is known for its incredibly high temperatures, which can reach up to 2,500 degrees Celsius. Despite the heat, it would feel cold to us because the air is so thin. The thermosphere is also where the auroras, those stunning natural light displays, occur, caused by charged particles from the sun interacting with atmospheric gases. This layer is vital for absorbing high-energy solar radiation and protecting the planet. Exosphere is the outermost layer of the atmosphere, gradually blending into outer space. It starts around 600 kilometers above the Earth and extends thousands of kilometers outward. Here, the air is extremely thin and particles can travel hundreds of kilometers without colliding. Satellites orbit in this region, and it marks the transition between our planet and the vastness of space. The exosphere may seem empty, but it still plays a role in protecting Earth from solar and cosmic radiation. Atmosphere is made up of a mix of gases, with nitrogen making up about 78% and oxygen about 21%. The remaining 1% includes argon, carbon dioxide, and trace amounts of other gases. Water vapor and dust particles are also present, playing a key role in weather and climate. This unique blend of gases is what makes Earth's atmosphere so special, supporting life and regulating temperature. Even small changes in this composition can have big impacts on our environment. Oxygen is a vital component of the atmosphere, making up about 21%. It's essential for the survival of most living organisms, as it's used in respiration to produce energy. Plants, animals, and humans all depend on oxygen to live. The balance of oxygen in the atmosphere is maintained by the process of photosynthesis, where plants convert carbon dioxide and sunlight into oxygen. This cycle is crucial for sustaining life and keeping our planet healthy. Nitrogen is the most abundant gas in the atmosphere, making up nearly 78%. While it doesn't play a direct role in breathing, it's essential for life. Nitrogen is a key ingredient in proteins and DNA, the building blocks of all living things. It also helps stabilize the atmosphere and prevent rapid combustion. The nitrogen cycle involving bacteria and plants ensures that this element is available for use by living organisms. Without nitrogen, life as we know it wouldn't exist. Carbon dioxide may make up only a tiny fraction of the atmosphere, but it has a big impact. It's essential for photosynthesis, allowing plants to create food and release oxygen. However, too much carbon dioxide can trap heat in the atmosphere, leading to global warming and climate change. Human activities like burning fossil fuels have increased carbon dioxide levels, making it a key focus in environmental discussion. Managing carbon dioxide is crucial for maintaining Earth's climate balance. The ozone layer is a thin region within the stratosphere that contains a high concentration of ozone molecules. This layer acts like Earth's sunscreen, absorbing most of the sun's harmful ultraviolet rays. Without the ozone layer, life on Earth would be exposed to dangerous radiation, increasing the risk of skin cancer and harming ecosystems. Efforts to protect the ozone layer, such as reducing the use of certain chemicals, have shown positive results, highlighting its importance for our planet's health. Atmosphere acts as a shield, protecting us from a variety of dangers. It blocks harmful solar radiation, burns up meteors before they reach the ground, and helps regulate temperature by trapping heat. This protective role is vital for maintaining stable conditions on Earth, allowing life to thrive. Without the atmosphere, our planet would be a hostile place, exposed to extreme temperatures and constant bombardment from space debris. There is a direct result of the atmosphere's interactions with the Sun and Earth's surface. The movement of air masses, the formation of clouds, and the distribution of moisture all depend on atmospheric conditions. Changes in temperature and pressure drive winds and storms, shaping the weather we experience every day. Understanding the atmosphere helps meteorologists predict weather patterns and prepare for extreme events like hurricanes and heat waves. It's important to distinguish between climate and weather. Weather refers to short-term changes in atmospheric conditions, like rain, sunshine, or wind. Climate, on the other hand, describes the average weather patterns over a long period, typically decades. The atmosphere plays a key role in both, influencing daily weather and long-term climate trends. By studying the atmosphere, scientists can better understand how our planet's climate is changing and what that means for the future. Atmospheric pressure is the force exerted by the weight of the air above us. It decreases as you go higher in altitude, which is why your ears might pop when you fly in an airplane or climb a mountain. Changes in atmospheric pressure are closely linked to weather patterns, influencing wind, clouds, and precipitation. Understanding pressure helps meteorologists forecast storms and other weather events, making it a key concept in atmospheric science. Temperature in the atmosphere varies with altitude and location. In the troposphere, temperature drops as you go higher, while in the stratosphere it rises due to the ozone layer. These changes affect weather, cloud formation, and even the types of life that can survive at different heights. The sun's energy is the main driver of atmospheric temperature, creating the conditions necessary for life and shaping our planet's climate. Humidity refers to the amount of water vapor present in the air. It plays a major role in weather and climate, influencing how comfortable we feel and how clouds and precipitation form. High humidity can make temperatures feel warmer, while low humidity can lead to dry conditions. Water vapor is also a greenhouse gas, helping to trap heat in the atmosphere and regulate Earth's temperature. Monitoring humidity is essential for weather forecasting and understanding climate change. Wind is simply air in motion caused by differences in atmospheric pressure. When air moves from high-pressure areas to low-pressure areas, we feel wind. Winds can be gentle breezes or powerful storms, shaping weather patterns and even influencing ocean currents. The atmosphere's movement helps distribute heat and moisture around the planet, making wind a key player in Earth's climate system. Clouds form when water vapor in the atmosphere cools and condenses into tiny droplets. These droplets cluster together, creating the clouds we see in the sky. When enough moisture accumulates, it falls as precipitation: rain, snow, sleet, or hail. Clouds and precipitation are essential parts of the water cycle, helping to distribute water across the planet and support life. Greenhouse effect is a natural process where certain gases in the atmosphere trap heat from the sun, keeping Earth warm enough for life. Without it, our planet would be too cold to support most living things. However, human activities have increased the concentration of greenhouse gases, leading to global warming. Understanding the greenhouse effect is key to addressing climate change and protecting our environment. Human activities, such as burning fossil fuels, deforestation, and industrial processes, have significantly altered the atmosphere. These actions increase greenhouse gases, contribute to air pollution, and deplete the ozone layer. The consequences include global warming, more extreme weather events, and health problems for people and wildlife. Recognizing our impact on the atmosphere is the first step toward making positive changes for the future. Air pollution occurs when harmful substances are released into the atmosphere, often from vehicles, factories, and agriculture. Common pollutants include carbon monoxide, sulfur dioxide, and particulate matter. These pollutants can harm human health, damage ecosystems, and even affect weather patterns. Reducing air pollution is essential for protecting both the environment and our well-being. Acid rain is a type of precipitation that contains higher than normal levels of acidic compounds, usually caused by air pollution. When pollutants like sulfur dioxide and nitrogen oxides mix with water vapor, they form acids that fall to the ground as rain, snow, or fog. Acid rain can damage forests, lakes, and buildings, making it a serious environmental issue. Efforts to reduce emissions have helped, but acid rain remains a concern in many areas. Smog is a type of air pollution that forms when sunlight reacts with pollutants like vehicle emissions and industrial fumes. It's especially common in large cities where traffic and factories are concentrated. Smog can cause respiratory problems, reduce visibility, and harm plants and animals. Addressing smog requires reducing emissions and improving air quality standards in urban areas. Ozone depletion refers to the thinning of the ozone layer, mainly caused by chemicals called chlorofluorocarbons (CFCs). When these chemicals reach the stratosphere, they break down ozone molecules, reducing the layer's ability to block harmful UV rays. International agreements like the Montreal Protocol have helped reduce CFC use, but ozone depletion remains a global issue. Protecting the ozone layer is vital for safeguarding life on Earth. Global warming is the long-term increase in Earth's average temperature, mainly due to rising greenhouse gas levels. This warming leads to melting ice caps, rising sea levels, and more frequent extreme weather events. The atmosphere's ability to trap heat is being intensified by human activities, making global warming one of the most pressing challenges of our time. Addressing it requires global cooperation and sustainable solutions. Climate change is already affecting the planet in many ways. We're seeing more intense storms, longer droughts, and shifting weather patterns. These changes impact agriculture, water supplies, and even human health. The atmosphere's delicate balance is being disrupted, making it crucial to understand and address the causes of climate change for a sustainable future. The atmosphere is essential for life on Earth. It provides oxygen for breathing, carbon dioxide for plants, and protection from harmful radiation. The balance of gases supports diverse ecosystems from forests to oceans. Changes in the atmosphere can have far-reaching effects on all living things, highlighting the need to protect this vital resource. Photosynthesis is the process by which plants use sunlight, carbon dioxide, and water to produce food and release oxygen. This process is fundamental to the atmosphere's balance, as it removes carbon dioxide and replenishes oxygen. Forests, grasslands, and oceans all play a role in photosynthesis, making them crucial for maintaining a healthy atmosphere and supporting life on Earth. Respiration is the process by which living organisms take in oxygen and release carbon dioxide. This exchange of gases is vital for life and helps maintain the atmosphere's balance. Animals, plants, and even microorganisms participate in respiration, creating a continuous cycle that supports ecosystems and keeps the air breathable. Atmosphere is a key player in the water cycle. It transports water vapor from oceans and lakes to the sky where it forms clouds and eventually falls as precipitation. This cycle distributes water across the planet, supporting agriculture, ecosystems, and human life. Without the atmosphere, the water cycle wouldn't function and life as we know it would be impossible. Sound travels through the atmosphere as waves of pressure. Without air, we wouldn't be able to hear anything since sound can't travel through a vacuum. The atmosphere allows us to communicate, enjoy music, and experience the world in a unique way. Changes in atmospheric conditions like temperature and humidity can even affect how sound travels. Atmosphere affects how we see light from the sun and stars. It scatters sunlight, creating blue skies during the day and colorful sunsets in the evening. The atmosphere also filters out harmful rays, allowing only safe wavelengths to reach the surface. This interaction with light shapes our experience of the world and protects us from danger. Atmosphere is crucial for aviation. Airplanes rely on the density and movement of air to generate lift and stay aloft. Pilots must understand atmospheric conditions like wind, turbulence, and pressure changes to fly safely. The stratosphere, with its stable air, is often used for long-distance flights. The atmosphere's properties make modern air travel possible. Satellites orbit the Earth in the exosphere, the outermost layer of the atmosphere. This region offers minimal air resistance, allowing satellites to move freely and gather data on weather, climate, and communication. The exosphere is essential for modern technology, connecting people around the world and helping us monitor our planet from above. Space travel requires passing through the atmosphere, which presents both challenges and protection. Rockets must overcome atmospheric drag and heat during launch, but the atmosphere also shields us from meteors and radiation. Understanding atmospheric layers is crucial for designing spacecraft and ensuring safe journeys beyond our planet. Earth isn't the only planet with an atmosphere. Mars, Venus, and even some moons have their own unique atmospheric compositions. Studying these atmospheres helps scientists understand how planets evolve and what conditions are needed for life. Comparing Earth's atmosphere to others highlights just how special our planet really is. Career in atmospheric science offers many exciting opportunities. Meteorologists, climate scientists, and environmental engineers all study the atmosphere to understand weather, climate, and air quality. Their work helps protect communities, improve forecasts, and address global challenges like climate change. If you're curious about the world around you, atmospheric science could be a rewarding path. Protecting the atmosphere is everyone's responsibility. Simple actions like reducing energy use, conserving water, and supporting clean energy can make a big difference. Governments and organizations are also working to reduce emissions and promote sustainable practices. By working together, we can ensure a healthy atmosphere for future generations. Technology plays a big role in studying and protecting the atmosphere. Satellites, weather balloons, and advanced sensors collect data on air quality, weather, and climate. This information helps scientists make accurate forecasts and develop solutions to environmental problems. Technology is a powerful tool for understanding and safeguarding our atmosphere. Atmosphere affects us every day, from the air we breathe to the weather we experience. It influences our health, comfort, and even our moods. Paying attention to air quality, weather forecasts, and environmental issues helps us make informed choices and stay safe. The atmosphere is a constant presence in our lives, shaping our world in countless ways. Did you know that the atmosphere extends over 10,000 kilometers above the Earth, or that the highest clouds form in the Mesosphere? The atmosphere is full of surprises, from the colors of sunsets to the sounds of thunder. Learning about the atmosphere can be both fun and fascinating, revealing the wonders of our natural world. The future of the atmosphere depends on the choices we make today. By reducing pollution, conserving resources, and supporting science, we can help preserve this vital layer for generations to come. The atmosphere is resilient, but it needs our care and attention. Together, we can ensure a bright and healthy future for our planet. In summary, the atmosphere is much more than just the air around us. It's a complex, dynamic system that supports life, shapes weather and climate, and protects our planet from harm. By understanding and caring for the atmosphere, we ensure a healthy environment for ourselves and future generations. The atmosphere truly is one of Earth's greatest treasures.